Alright guys, today we are doing a little section called comparing linear functions and their graphs. And whenever they ask you to compare things in mathematics, most of the time, what they're asking you to do is state, which one is bigger, which one is smaller, which one has the greater value or what have you. So when you see that word comparing, especially in math, you just want to think you want to find out which one's bigger or which one's smaller and tell us that. All right. So let's take a look at number one here. It says a function describes the volume of water, which is going to be y, that flows from faucet A in gallons for X minutes. Okay, and they have the graph on the right here that is describing this linear function. All right. Now remember when we say linear function here, that means it behaves like this equation, right? Y equals mx plus b. So if this is the graph that describes faucet A, then I could come up with an equation that would describe it. All right. So let's try to do that before we answer any questions here. We know it's going to look like y equals mx plus b, so I need to find my slope. Well, in order to do that, I need to take a couple points and figure out change in y over change in x. So I see this point right here that is a good point to use because it falls right where these coordinates come together. So that is the point 7, comma 4. Oops, we gotta move that up a little bit. All right, let's move that. There we go. Okay, so this is the point 7, comma 4, right? And let's use this point right here. Whenever my function goes through 0, 0, I like to use that one because those are real easy numbers to work with. All right. So my slope, remember my slope equation is the change in y. So I'm going to subtract the y's over the change in x. So I'm going to subtract my x's. All right. So what would I have here? I'd have 4 minus 0 over 7 minus 0. So that means my slope is 4/7. All right, so there's my m. Now, what would my b, my y-intercept be? Well, the y-intercept is where it crosses the y-axis, and that's the point 0, 0 here. So b is 0. So that means my equation that describes this graph is 4/7 y equals mx plus b, and in this case, b is 0. So here it is. Here's my equation that describes faucet A. All right, so that's a good place to start. Okay, now it says over here, faucet B, the water flow can be described by the equation 5, 6x. All right, so they already gave me the equation, and in this case, my slope is 5, 6, and same thing, my y-intercept is 0. Okay, so what is the first equation here, or first question? Assume the water flow from each faucet is constant. All right, that's good. And which faucet has the faster rate of flow? All right, well, the rate of flow, remember we've said a few times the rate of flow, that is, you can think of that as your slope. All right, so in faucet A, I'm going to write that down here, faucet A, the slope is 4/7. Okay, in faucet B, the slope is 5, 6. All right. Now, some of you may not be able to look at that and say, oh, yeah, I know which one is bigger. So if you don't, then we'll call up the calculator here, and we'll take 4 and divide by 7, and that gives me a decimal of point 0.571. All right. And then I'll take faucet B, and I'll do 5 divided by 6, and that's 0.83 repeating. All right, so 0.833 if I round off. So when they say compare, all right, which one has the faster rate of flow? Well, it'd be the higher number. So this one right here, so faucet B is my answer to the first part here, has the faster rate of flow. All right. Okay, let's turn that off and let's go to the next question here. Each faucet is being used to fill tubs with a volume of 50 gallons. So I have this tub. All right. And we put a little feet on here for my tub. Okay, and we have this little faucet that we're starting to fill this tub, and it can hold 50 gallons. All right, so we'll put 50 gallons can go in this tub. Okay, and how long will it take each faucet to fill the tub? All right, now here's the beautiful thing about having the equation, having the function. All right, we'll do faucet A right here, and I know faucet's A equation is y equals 4/7 x. Well, what I want to happen is I want to know when that hits 50 gallons. All right. Well, make sure you plug that in for the right variable here. The gallons. If I go back up to my problem, the gallons is the y variable. All right. So I'm going to plug in a 50 for y, and now I'm just going to simply solve this for x. Right? So how do I solve that for x? Well, I divide. Okay, I divide both sides by 4/7. Divide by 4/7. Okay, and that's going to give me what? I got to bring up a calculator. I'm going to go 50 divided by. Now watch what I do. I'm going to put 4/7. So I'm going to put a parentheses so that the calculator sees that as 4/7. And I hit equals, and I get 87.5. So that's going to take that faucet 87.5 minutes, all right, to fill up that tub. All right, now what about faucet B? All right, we'll do faucet B here. And faucet B has an equation of y equals 5/6x. Okay, and I want the same thing. I want to know how long this is going to take for 50 gallons. So I just plug a 50 in for the y. And I'm going to divide by 5/6 on both sides. What is that going to give me? I'm going to have to bring up my calculator again, and I'm going to take 50, and I'm going to divide, and again I'm going to use my parentheses so it knows that I have a fraction in there. There's the fraction, 0.8333. Remember that from before, but I want to actually do the math. I want to actually 50 divided by that, so I hit my equals and I get 60. That's nice, right on the money. So 60 minutes. All right, it takes for faucet B. Okay? All right, so you see, once again, once you have the equations, it's just a matter, a lot of times, just plugging in the numbers that you get, and you plug them in the right place and plug or solve for the thing that you don't know. All right, so let me turn this one off, and let me turn this next one on here. Now it says the tub that is filled by faucet A already has 15 gallons in it. Okay, here's where we're going to change this equation up here. All right. Now, before, when I made this equation for faucet A, it had 0 gallons in it to start. That's why my y-intercept over here was 0, 0. But now we're changing things. Okay, it's still going to flow at 4/7. That's going to be my slope. It's still going 4 gallons per minute, right? Or I'm sorry, 4 gallons per 7 minutes. But now I already had 15 gallons in it. So what that's going to do is that's going to take this line, it's going to shift it up, right? At time 0, we already had 15 gallons. It would actually start up here at 15. So my y-intercept is now 15. This is my new equation given this information. All right? So if both faucets are turned on at the same time, which faucet will fill its tub faster? All right? Now if we go back to the previous example here, faucet B took 60 minutes, right? So I'm just going to write that down. I'm going to say faucet B took 60 minutes because we're not going to change that at all. We want to compare that now. What if faucet A is now got 15 gallons to start? Well, what do? Well, we do the same thing. We want 50 gallons total, right? So we're going to plug a 50 in for the y again, but now I need to solve this equation. I need to take away 15 first. All right, so I get 4/7 x equals, now 50 minus 15 is going to give me 35. All righty, and then we're going to divide both sides of this by 4/7. Okay, and I'm going to have to bring up the calculator in order to do that. So let's see, that's going to be 35 divided by, and again I'm using my parentheses here, 4/7, close parentheses, hit the equals. Okay, so that's 61.25. So x equals 61.25 minutes. All right, and they want to know which one's going to take, or which one's going to do it faster. All right, okay. Well, that's didn't really want to cross that out, but which one's going to do it faster? Still, faucet B. Faucet B is still going to fill it faster because this is less than this 61.25 minutes. All right, so I think that those are all the parts to this first equation, or for this first problem. So I'm going to clear the screen off here, and we'll go on to number 2. Okay, here is exercise 2. This one's a little different. It doesn't ask quite as much, but there is a little work to do in here. It says 2 people, Adam and Bianca, are competing to see who can save the most money in 1 month. Now, it doesn't tell you this in the problem, but what we're going to find out is that they are each saving the same amount in like over the course of each day. All right, so it says use the table and the graph below to determine who will save more money at the end of the month. All right, and they also say state how much money each person had at the start. Okay, so we're gonna start with Bianca here, and if you look at where they start you, they don't start you at day 0. All right, so that's what makes this a little harder, is you don't know how much she started with, okay? But what you can do is you can figure out the slope in between some of these points, and that will allow you to make an equation and figure out what her y-intercept is, which is when the number of days was 0, all right, when x was 0. All right, so that's where I need to start here. I need to start by figuring out the slope, like how much is she saving each day. All right, so I'm going to put my slope equation up here and make that a 2. My slope equation looks like this. All right, and I'm just going to pick 2 of these points. I'm going to take these first 2 here, and this would be my x, and this would be my y values. So I would have points, like if I made points out of this, a coordinate pair, this would be 5, 17, and this one would be 8, 26. All right, and if I figure out the slope in between those 2 points, let's see what we get. We have 26 minus 17, there's my y values, and 8 minus 5. So what do I get here? I get 9 over 3, which is $3, okay, in this case, all right, where she's saving $3 per 1 day, since that 3 is really like 3 over 1, all right. Now let's just make sure that this is staying constant. Let's take these 2, okay, it doesn't have to be those 2, but I just picked those 2. That would be 12, 38, and let's see, this would be 20 minus, or 20, 62. All right, and I'm going to do the slope over those 2. Let's see if she's saving the same amount per day. All right, so this would be what, 62 minus 38, and this would be 20 minus 12. Okay, so that's going to be an 8 down there. All right, up top here you subtract those. That's going to give you 24. And look, it comes out the same. So what the moral of this story here is that she's saving the same amount per day over the course of these days. All right, so this is in fact a linear function. This is going up by the same amount every day. So what that tells me is her equation, if I come up with an equation, it's going to take in the form y equals mx plus b. Okay, now the slope I just figured out, that's a 3. I don't know what the y-intercept is, though. The y-intercept, if I can write it up here, that would be at day 0. And I don't know what her output is. That's going to tell me how much she started with. Okay, now if you guys remember, we did this a few weeks ago where so far, this is what I have. Y equals 3x plus b. And we said, well, when you want to figure out your y-intercept, if you know a point that works, you can plug in that point and figure out what b is. So let's take this point right here. Since these are the smallest numbers, why not use the smallest numbers, right? So let's take 17, plug it in for y. Let's take a 5, plug it in for x. See, I'm getting that right here. Okay. Now I should be able to solve this for b, and it's pretty easy. All right, that's 15. And I'm going to take away 15 on both sides. And so b equals 2. All right, so that means, okay, if I can sum up here, y equals 3x plus 2. That is the equation that describes Bianca's situation here. All right, and we can answer one of these questions. It says, state how much money each person had at the beginning. Well, now I can take out this question mark here, right? And I can put a 2 because I got the y-intercept to be 2. All right, so she had $2 to start. Okay, we'll just put that right down there. All right, now let's try to do the same thing with Adam's money, but this might be a little easier since they gave us a graph to work with Adam. All right, you can see it's a straight line, so his equation also is in the form y equals mx plus b. All right, but let's fill in numbers we can here. Look at, we know the y-intercept right here. This is the y-axis, and when x is 0, y is 3. Okay, so that gives us something to start with. So our equation looks like that. All right, my y-intercept is 3. Now, could I figure out my slope? Well, sure. Okay, here's a point. This is 0, 3. And this point right here, look, it goes right through. That's a nice point to use because this line goes right over this specific coordinate. That coordinate is, what is it? 2, 9. Okay, so I'm going to use those points to figure out my slope. Okay, I'm going to switch over to red here. So slope, I'm not going to write it down again because it's right here. All right, I'm going to subtract the y's, and I'm going to subtract the x's. 9 minus 3, and we got 2 over 0. So what is that going to be? 6 over 2, which is $3. Okay, so it looks like they're saving the same amount every day. All right, so what's his equation now? I'll switch back to blue here. Now his equation, I've already got my y-intercept, right? So his equation is now 3x, right? I just figured out my slope, so I put that in for m, plus 3. Okay, so this is Adam's equation. All right, we'll put Adam right there. And this is Bianca. All right. So they're saving the same amount each day. Well, if Adam started with $3 and Bianca started with $2, well, at the end of the month, if they're saving the same amount each day, then wouldn't Adam have the most at the end of the month? Okay, so it does say state how much money each person had at the beginning of the competition. Well, she had $2. He had $3. Okay, we can write that up here. $3 to start. Okay, and who will save more money at the end of the month? Well, we've already determined it's Adam. And if you want to prove it, well, let's take 30 days. All right, let's take 30 days to be 1 month. I know some months have less, some months have more, so we'll just take 30. And if I plug a 30 in for x, because x is my number of days, if I plug in a 30 here, I get 3 times 30, which is 90. I get $93. Okay. If I plug a 30 in for Bianca's equation, I got a little space over here. I'm going to do it right here. All right, 30. Oh, that's a terrible 3. Let's fix that. All right, 3, and I plug a 30 in here. Well, hers only comes up to $92. So obviously he's going to save more by $1 at the end of the month. All right. So that's kind of the type of questions that we're looking at for tomorrow. All right, so if you need to go back and see a little part of that, then please do. Other than that, thanks for watching and have a good night.